Welcome to my world. Another day, another time, another period for knowledge acquisition. Knowledge is power, health is wealth. Today's topic is G6Pd and hemolytic anemia. That sounds strange to so many people because I'm sure the full meaning of G6Pd is not clear. It is glucose 6-phosphate dehydrogenase. It is one of the enzymes problem. But some have it and some don't. But the usual thing is when you have it, there are certain things you react to. The commonest of which is the drug called prematurely, and those days you start serious reactions, and the hemolysis will present with serious anemia, and which may affect the kidney. But the essence of today's knowledge is to expose us to G6Pd and link it with hemolytic anemia, as well as linking it with antioxidants, so that we can acquire more understanding on these antioxidants as well as hemolytic anemia and what G6Pd stands for. So if you like what you are listening to, press the like button, subscribe, and it shall be there. G6Pd and hemolytic anemia. Let's look at the outline, the objective, and the introduction. The G6Pd link with hemolytic anemia, G6Pd links with antioxidant, and finally the conclusion. The objective is to create the necessary awareness to one of the most common human enzyme deficiencies in the world, to also expose us to the possibility of G6Pd being recommended as an anti-wrinkle or aging enzyme in the future. The introduction. The red blood cells perform the role of carrying oxygenated blood to every tissue of the body. This glucose is the energy source of RBCs to perform that function, and glycolysis is the way of getting the energy involved, and this involves the enzyme G6Pd, which helps every cell to prevent cellular damage. So if there is a deficiency of G6Pd, there will be cellular damages, which explain why red blood cells disintegrate prematurely. But where it is there, you can see the integrity of the red blood cells fully intact. But when it is lacking, there is that destruction of red blood cells breaking to pieces prematurely. Hemolytic anemia is therefore explained. It's a blood condition that occurs when RBCs are destroyed faster than they are replaced. The body replaces after 120 days every RBC. So you have situation of sickle cells, thalassemia, hereditary red cells membrane disorder, pyruvate kinase deficiency, and the one of concern is G6Pd deficiency, which we shall examine very, very well. The G6Pd deficiency linked with hemolytic anemia. During G6Pd deficiency, the red cells are unable to regenerate, reduce nicotinamide dinucleotide phosphate (NADPH). This heightens the oxidative stress because more GSSH disulfide glutathione are accumulated, which are reactive with the cell membrane to create that damage, and which result in anemia, jaundice, and possibly kidney damage in no time, especially in children who take drugs like prematurely that induces hemolytic anemia. It is that problem of regenerating the glutathione. You can see that is being explained here, where the G6Pd absence will not allow the process to go on and will result in this glutathione not reduced. The reduced glutathione helps to protect red blood cells membrane from oxidative stress. Is that disulfide glutathione that is really needed to now produce the reduced NADPH. This is also done here. You can see the reduction of the NADP by hydrogen addition, and the same thing being explained. The oxidant effects damage the red blood cells membrane. Hemoglobin changes into antibodies and impair synthesis of glutathione, which is necessary for regeneration. So the G6Pd linked with antioxidant. The ROS are generated as a result of normal intercellular metabolism by the action of several external agents. According to the researcher, the level of NADPH determines the rate of ROS derivative damage. Mammalian cells possess few enzymes able to produce this NADPH, and among them, G6Pd is considered the most important one. So G6Pd and the pentose phosphate pathway in ROS detoxification is proven in their research with mice, and you can then now project that in future the G6Pd may be a source for anti-aging. This is also to explain the free radicals. The free radicals producing hydrogen peroxide, which really attacks the cell membranes and cause cellular damage. The oxidative damage to hemoglobin and the membrane is done by these free radicals. But in the presence of the enzymes, the glutathione peroxidase, it is turned to water, as then the G6Pd dehydrogenase also help to return reduce the NADP to NADPH. In that process, it helps the cycle to continue. That is, the disulfide glutathione is now reduced again to glutathione. Things to avoid if you have that deficiency: you avoid all beans, legumes, the least, quinine, the primaquine, quinolone, sulfur, antibiotics, nitrofurantoin, so that when somebody is given, he really has to explain that. The lab diagnosis involve, you can take so many other ways to really diagnose it, by absolute reticulocyte count, Coombs test, cold agglutinins, platelet counts, and many other ways. But when you want to test for the activity of the G6Pd enzyme, is a sure way. Since the X chromosome carries the gene for G6Pd, this deficiency mostly affect the males. In women, it has variants, and these are the variants commonly. This last one is complete deficiencies, which does not need anything. It's a congenital non-serocytic anemia without drug oxidative stress. In this other one, 90% or more, it's induced by oxidative stress. And the class 3, you find the oxidative drug infection induced self-limiting hemolysis without previous hematological disorder. These are various classes of the disorder, and 40% with milder clinical condition depending on the variant. The values of the G6Pd you get is usually the set deficiency up to 20% correspond approximately to normal range of these values listed here. These are the references for you to peruse.